Last one, circle problems. I only give you 4, and I'm asking about 4 things, so there's going to be one of each, okay? I'll give you one that says find the area of the circle, one that says find the circumference of the circle, one that says it finds the arc, one that says find the sector, okay? So let's first talk about area and perimeter, or circumference. Area of a circle, what's our formula? It's going to be a pi, a 2, and an r in there somewhere, right? We just don't know if the 2 is squared or not. Area is always squared, right? So let's put down our pi and our r and our r. And then where does our 2 go? Is it going to be squared or is it going to be a 2 out front?
2 pi r.
Nope. Area is always squared.
Oh, okay.
Yeah, so we're going to put our 2 up here. That's how I remember
What's
it.
2 pi r?
That's circumference.
Circumference.
Right? Area and perimeter, they all have the same 3 things, a 2, a pi, and an r. The question is the 2 going to be a square, or are we just leaving it alone? Area is always squared, so I put it up there. That's how I remember which is which. Area is always squared, so the 2 is squared in area formula, okay? So now we've got this. This is our radius. We know that. If I give you a radius of 3, what's the area? Well, let's plug it in. A equals pi times our r, which is 3 squared. What's 3 squared? 9. Leave the pi alone. 9 pi. Units squared. You could plug that into your calculator and get an exact number, which would be 9 times 3.14 whatever, units squared. Or you could just put it like that and not have to round or guess, right? This is so much nicer. This is how real math is done. Ain't nobody have time for those decimals. So that's all you gotta do for an area problem. What if I asked you for the perimeter, or the circumference of this guy? What's our circumference formula? There's gonna be a 2 and a pi and an r in there somewhere. Is the 2 gonna be a square or no?
No.
No, it's circumference, 2 pi r, done. So let's write that out. C equals 2 times pi, whoops, pi is here. And what's our r value? 3. Do the math, 2 times 3 is 6. Leave the pi alone. C equals this, 6 pi units. Not units squared, because circumference is the outside, right? It's like the fence, the perimeter. Circumference. That's it. That's 2 free problems for you right there, right? Pretty easy. That's another free 4 points. Last 2 things. Arc and sector. So if I give you a circle, and I could have used the same one from before, but I'm not going to. And I give you something like this, a radius here and a radius there. And I say this is 2. Well, we know this radius is also going to be 2, right? Because radii are always equal. If that's 2, this is 2. Yeah, okay. So if I didn't give you both of those, you could figure that out, right?
Right.
Okay, cool. Well, let's put it in. Who cares? And I ask you for the arc length from here to here. I could ask you from this to this, right?
Mm-hmm.
But I'm going to ask you here, the smaller one. And I'll give you the angle. I'll say the angle between these 2 is 90 degrees. Cool. So we could find arc length is the outside, right? Okay. Well, what's all of the outside for a circle?
360.
Well, what's the length of the whole outside? That's called the circumference, right?
Right.
Well, what's circumference? It's 2 pi r. If we want to know a piece of the circumference, which is really all that is, right? A piece of the circumference, we need to multiply that by a fraction. How do we find our fraction? Well, we have 360 total degrees, right? How many degrees are we asking about?
90.
90. That's our fraction. 90 over 360. Plug it into your calculator, do the thing, you're fine. Or simplify. I'm doing it in my head, so I'm going to change 90 over 360 to a simpler fraction, which is really just 1 over 4. Yes?
That's my question.
Oh, yeah. Yeah. Same thing. As long as you reduce it correctly, right? If you write 1 over 6, then you're going to get the wrong answer. But if you can reduce fractions correctly, you'll be fine. So now we've got this. What's our r value? What's our r value? Yeah, happens. 2 times 2 is 4 pi times a quarter, right? 4 divided by 4 is another way of saying this, which is just 1 pi, or just pi, units, because it's not area. We're talking about the circumference, right? So it's just regular units. The distance from here to here is 3.14 repeating, or not repeating, but going on forever. Interesting how a number like that can exist in real life. Pi units. That's the length, the arc length. So you take the whole thing, which is the circumference, and find a fraction of it. So you plug in your circumference formula and put the fraction in. The fraction is how many degrees we're talking about. What if I ask you for the same circle to find the sector area? I'm going to throw a curveball at you. I want you to find the sector area of this. Find the area of that. Well, what's the area of the whole thing? It's going to be our area formula, which is pi. R, which we said was 2 squared. That's the whole thing. We want to find a piece of it, so let's find a piece of this. What's our fraction here? Out of 360 degrees, how many degrees am I talking about here? 3? Yeah, I know what you mean. How many degrees is that? It's 360 minus the 90 that I labeled, right? It's whatever's left over, which you said was 280? 270. Sorry, happens. That's why you have calculators. If you made a goof there, I'm going to give you 3/4 credit because I don't care if you can do arithmetic or not. I want to know if you understand the concept, right? You need to get this right. But if you said that was 280, dumb mistake, right? Happens. So 270 is our angle we're talking about here. This is a 270-degree angle right here. How did we find that? We took 360, all the angles, right, all the degrees, and subtracted 90 to find what was left over. That's like as hard as that gets. So 270 over 360, which is really just 3/4. If you don't know that, it's okay. You can plug in 270 over 360 into your calculator and do the math. Come out the same way. I'm doing it in my head, so smaller numbers are better. Simplify. What's 2 squared? So it's 4 pi times 3/4. These are fractions. It's really just 4 over 1 times 3/4. Multiply fractions. 3 times 4 is 12. 4 times 1 is 4 pi. Is that simplest form? No. 12 divided by 4 is what? 3 pi units squared is the area of the blue. I don't think those are bad. You got to know what you're doing, but like the math is usually pretty easy. I'm not going to give you a number like 3,000 is your radius and your degree is 8.725, right? I'm going to give you nice numbers. Show me you know what to do with them. That's it. That's the whole test minus the definitions, which I think you guys will ace, right? Definitions are not hard. I gave you guys the quiz, didn't I? Yes. Right? Or the test we took from chapter 9. It's those definitions, right? I've got them scrambled, but it's the same thing. Would you like to see now the thing we skipped, which is reflection and rotation? Yes, okay. Last thing and then we're done. We're almost there. Scott, are you good?
Yeah, I'm good.
Okay. Yeah, no problem, man. Hey, thanks for coming in. You know?
Help me out.
Well, I wish I didn't have to. You know what I mean? I wish you guys just got it in the time that we have in class. And I think you would, other than chapter 8.
Just too much to cram in. And
Right. But you know what? You've got 2 days to process, so watch the video if you've got questions. Yeah, right, yeah. Sorry. I figured it'd be better to give you guys some time if you did want to study between now and then and ask questions. Like if you come in Monday and like, that thing you talked about, what? I don't understand that, right? I did then, now I don't. Now you've got time.
yeah.
Whereas if I teach you it, less than 24 hours before in a review, not so good. All right, thanks for coming in, Scott.
Yep, thank you.
Or Kyle, excuse me. I'm not allowed to call you Scott.
Yeah, right.
All right, smartboard. Found you. Ooh, how are we doing? Is that really 4:30? Did I go too quickly through this? I thought I was taking too long. Probably did.
Mr. Mac, should I take this thing off the door? Just want to put it back, or should I go out a different way?
Can you go out the parking lot way? You know what I mean, by the gym? Don't get eaten by ghosts. I hate working here late at night.
Maybe we're close.
They're real. They're totally real.
There's actually been a prank in our school for years.
Yeah, well, it's not a prank. There have been multiple teachers that have heard full basketball games going on, and then they go into the gym and no one's there. Like buzzers, crowd, everything.
Sometimes it's Spencer, he likes to mess with the teacher sometimes when he gets bored.
Well, he leaves late at night, and I'm here later than him. I'm here at like 11 or midnight sometimes, and I hear very strange things, like lockers slamming.
Yeah, it's weird.
And there's no one here because all the doors, you can't get in except for that one, and I totally would hear you coming in through that door. Yeah, lockers slamming.
Snazzy.
Or it is really creepy.
Dawn's got some
Or
fun
I
stories.
constantly see someone standing outside my door, and then when I go to check, there's no one there.
Oh,
Yeah, that's weird.
Fun.
that was like one time.
Miss Chase's mom.
We heard like Miss Chase's mom. We heard the story about Mr. Stephens like hearing stuff at like 3 in the morning. He just left.
Yep. There's music that comes out of the hole on certain days of the week. Country music. I'm guessing it's Oklahoma. I've never heard it, but my mom has heard someone singing the music from Oklahoma in the gym, performing it, and then she goes in there and no one's there. Yeah, so I'm guessing it's someone performed a musical back in, 100 years ago when the school was built, and they're coming back to sing it again,
When they say you don't need Newark, you literally do not need Newark.
No. It's interesting. And it's never like mean ghosts, it's just like memories, so it's like, oh, okay, whatever. They're checking me out, like, what's he doing here,
It's like,
Why are you in my classroom?
This is the most haunted room I've been told, because it's one of the only rooms that still existed from the original school. Because this used to be the old entrance,
Yeah,
right?
because that was the teacher's lounge.
Yep. And I am in room 1, first room.